Hi, this is Chris. I wanted to explain what I was doing with these fraction comparisons. So I took 6/9 and 5/8, and I thought of them in terms of music. And in music, we're going to divide our music into equal length units of length called measures, and then within that measure, we have different divisions for the rhythms. So what you see, these two red lines here would represent a measure. So for the 6/9 measure, I have to put it in a 9/8 meter, which means that I have 9/8 notes in each measure. So if we look here, we have 1, 2, 3, 4, 5, 6, and then this symbol here represents three resting units, 7, 8, 9. So we have 9 units of within this measure. It's 9 divisions of that measure. And we can model this using the web metronome pretty easily. And I tried to use all free tools in this because I figured that would be better for thinking of a classroom application. Wanted to have all free tools. So if we look here, I'm able to put out a palette with 9 beats, and then I can click on and off. I've clicked 6 of them on, 3, 4, 5, 6. And the cool thing about this is it will count them for you too. Okay, so that is the way that we can model 6/9. 5/8 is a little bit trickier when you start using free drum tools, because in music we don't really, whenever we have an 8 subdivision in the time signature, we're really going to start having compound subdivisions, and it's not going to quite, it gets kind of complicated, and there's not a lot of free online tools that allow you to do a complicated meter like 8/8. There are a lot that will allow you to do 4/4. So if we just convert that, use the equivalent fraction, and go to 4/4, it's really easy. It doesn't actually change anything. You see, I still have eighth notes here. 1, 2, 3, 4, 5 eighth notes. And then these symbols in this meter also represent 3 beats of rest. 1, 2, 3. So 5 on, 3 off, 8 eighth notes total. We just have to write it in this time signature of 4/4 so that I can use the free online resources. In this case, I used the drum pattern sequencer. So you see here I have a palette. I get 8 columns. These represent the divisions within the whole. And then I can click 5 on with these sounds. And then I'll just have a resting sound for these 3. 2. Here's 1, 1, 2. Pretty cool. But of course, the challenge was not to just model the fractions, it's to compare them. So where this gets tricky is I have one measure where I've fit 9 eighth notes, and I have one where I have 8 eighth notes. So I have to find the ratio between those two. And I did that with using a unit fraction for the 9 because it will be easier for the programming end of the tempos. So I used 9, and then I found the unit of 0.8 repeating for each one in the 9. So, sorry about that. So then we get at a tempo of 120 beats a minute, a real steady tempo, the measure with 8 eighth notes in it is going to have to be 106.6 beats per minute. Okay, these are just the way we do different tempos, the way we notate them. So you have to have your tempos match up, and you do that by setting up a ratio. So if you look, that's kind of what I've done, but we had to put this in half because we're using the quarter note as our base. We're using the 4 as our base instead of the 8. So you'll see I've divided the 106.6 by 2, and then you get 53.3 repeating, and then I simplified that, or estimated that, rounded it to 53. Rounded it, sorry. So this is where we get the 53 for this versus the 120 for this. You see the tempo here is 120. And so then I can play 53 here. Now let's start the 9 beat cycle on the next one. 2, go. And while it may not sound great, they actually do line up. And what you can do is you can go into a program like Audacity and you can actually create a graphic of it. Here, there's the same thing in Audacity, and what I did is I amplified it a little bit and added some reverb so we can see the pull of these. And you'll see they mostly hit exactly together. And you can also see, here's our 9, and you can see that in that 6-9, the divisions are quite a bit smaller than in the 8. And you can see these are the 5/8 that are on right here. I'll highlight those. That's the 5/8. And you can see how that compares with the 6/9. So that's one way I thought of modeling it. It doesn't sound great necessarily, but there's actually some things you can do to make it sound better. And I thought it was really interesting to just look at it that way.